Hello ladies and gentlemen, here's our first video into chapter 2. We're just going to start with some real basic information, and we'll do the majority of this as a group in class tomorrow. I just want to introduce to you the main symbols and some of the meanings of them before we start doing the calculations in class. We're going to talk about the metric system. And the metric system has 4 base units for the most common things you've always calculated. Length of stuff, mass, time, and volume. The length has a base unit of a meter, and the mass has a base unit of a gram. And time has the base unit of a second, SEC, and volume has a base unit of liters. And what we're going to do is we're going to put prefixes on those. And you have actually heard of these in the past. We'll just introduce them formally to you now. What goes in front of the base units change the value of the unit. There's the prefix mega, which has the symbol big M, and it is 10 to the 6, so 10 with 6 zeros after it. There's kilo, which you're very familiar with. It's a small k, and it's 10 to the 3, so that's like 1,000. Kilogram, 1,000 grams. You've seen that many times. Deci is a small d, it's 10 to the negative 1, so that's like 0.1. Centi is a small c, 10 to the negative 2, it's kind of like hundredths. Milli is 10 to the negative 3, it's a small m. And micro is 10 to the negative 6, it's like an italicized u. And that's actually a pretty good looking one, by the way. Those are the prefixes that we're going to put in front of the base units to do metric conversions in class tomorrow. These right here deal with volumes. So 1 milliliter is a centimeter cubed. Think of it as a centimeter by centimeter by centimeter, kind of like a box. That's 1 milliliter. A meter cubed is 1,000 liters, and a ton is 1,000 kilograms. So just to get you thinking about this stuff in a slightly different way, if you see the word 5 kilograms, well, we can write this out in 2 different ways, and you're going to be doing some of these conversions in class. So 5 kilograms is simply 5 kgs. There's kilogram. Or we can write it out with numbers. You can write 5, and kilo is times 10 to the 3, and the base unit stays the base unit, grams. So all 3 of those are the same thing. The kilo is the k, or 10 to the negative 3, and the grams stays grams the whole time. Just to do it differently, 2.3 to the 10 to the negative 3, well, 10 to the negative 3 is milli, so this could be 2.31 times 2.31 milliliters. Or you can write it out in words, but who would want to do that? But we will once. 2.31 milliliters. Again, 10 to the negative 3 is the milli, and the liters is the base unit. It stays there. Some of the other conversions that we're going to be dealing with are for things with like temperature. Canada and the US, we measure temperature differently. We use the metric system, and they use an imperial system. Well, we have Celsius with degrees C, and they have Fahrenheit, check the spelling I did before I wrote this out, is just degrees F. And there's a couple formulas that you can use to convert between Fahrenheit and Celsius to Fahrenheit. You will be given these on quizzes and tests. This is nothing you need to memorize. I'll give you the formulas. You just plug in the numbers. So for example, if I give you Fahrenheit and ask you to find Celsius, you just type in your calculator 5 over 9 bracket, the number Fahrenheit, minus 32 end bracket. And if you're given Celsius and you're asked to find Fahrenheit, well, you just type in Celsius, and it's the opposite. So it would be 9/5 times that number plus 32. In science and chemistry and physics, we use what's called the Kelvin scale for temperature. And it was invented by a guy named Kelvin, and he figured out that the coldest temperature absolutely possible on Earth is negative 273.15 degrees. Well, because that's a pain in the butt number to work with, we just say 0 is sort of where we start. 0 degrees is when water freezes. So to compare everything to Kelvin and 0, we just add 273.15 degrees to it. So if I give you this number, you add 273 and you get Kelvin. If I give you Kelvin, well, you subtract 273 and you get Celsius. Pressure is a little different. Pressure has been changed over the years, and there's some pretty crazy units in regards to pressure. Now what we use is things called atmosphere. Atmosphere, you may have heard it before. Um, Atmosphere is the amount of weight pushing on you. And it changes. If you go below sea level, it gets heavier and heavier and heavier. Pressure increases. And when you get farther away from sea level, like the top of Mount Everest, pressure is going to decrease and decrease and decrease. The weight of the atmosphere is less on you, higher up. Well, it used to be measured in millimeters of mercury, mmHg, millimeters of mercury, with the use of a barometer. That's what this thing is. So the mercury would be in the bottom here, and as the pressure increases, the mercury would be pushed up. And the higher it gets would be the greatest distance the mercury would travel up. So the bigger the number, the greater the pressure, because it's being pushed up the tube. That's a little old school. It's used for a lot of things like predicting the weather, but most of the time we have devices that calculate pressure for us. It used to be called torr. I don't have any real history behind that, but 760 millimeters of mercury equals 760 torr. And the big conversion is 1 atmosphere is 760 millimeters of mercury, which is 760 torr. And then back in the day, they used to use pascals as a unit. And again, I don't know what we use pascals for now. You can look it up if you're curious. But a pascal is 101,325. Or you can put kilopascals with that prefix in front of it and call it 101.325. So 1 atmosphere is at sea level. So the 101.325 is the pascals you have at sea level. So we're going to be playing around with those numbers and those conversions in class. We are going to start right here tomorrow with full-on metric conversions. So we'll see everybody then.